Okay, Algebra 1 students, in this video we're going to walk through the first activity, activity 15.2, classroom supplies. So the purpose of this activity is to take what we just played with, okay? The idea that when you add the same number to both sides of an equation, you still end up with an equation that's true. And we're going to relate this to a situation in the real world that could happen. Okay? So here you've got a teacher and a classroom. Okay? And this teacher purchased some calculators and some measuring tapes. All right? And she paid this much money for them. Later, she realized she didn't have enough supplies. All right? So she placed another order of 8 of the same calculators and 1 more of the same measuring tape. And she paid $178.50. Okay? So here's a system that represents the constraints that we're talking about in this particular situation. Okay? So, I invite you to take a moment to think about this situation and then answer these questions. Okay? So here are the questions that are here. Okay? So hopefully you paused the video and hopefully you did try to answer the questions. So let's talk about this. So what do the solutions to the first equation mean? What does it mean? Okay? Well, what this means is just like with our trail mix examples, all right, just like that, that C and M represent, this situation represents all of the combinations of measuring tapes and calculators that can be bought for our constraint of $495. So as long as the answer equals 495, we're good. Okay? Likewise, this second equation represents all of the combinations of calculators and measuring tapes that equal $178.50. And once again, there are many answers to that equation. Okay? So they want you to find the solution. And I don't care at this point how you do it. Okay? You can look at this. Is it going to be easy to solve it by elimination? Think about that. Are 2 of these coefficients the same? No. Could you add or subtract it right away? No. Could you do substitution on this? Do you have a situation where you've got one of the variables already isolated without having to divide? Yes, you do. You have an M. But you could also graph this. Okay? And that's what we're going to do in Desmos right now. Okay, students. So you can see that I have just opened up Desmos and I've put our 2 equations in. And remember that in Desmos you have to use X and Y only. You can't use other letters in order to calculate things or to graph things. So, what is the solution to the system? Here it is. Remember, you click on where the two lines cross. And the answer is 21.5 and 6.5. Okay? And so before we move on, I apologize for the long pause there, but I was thinking about how I wanted to say this next part. And I didn't shut off the recorder fast enough, so I apologize. Anyway, I need you guys to understand that yes, you have the choice to skip through and not really answer these questions, but you are hurting yourself when you do that, because the purpose of these questions is to get you to think. And if you don't think in this curriculum, you're not going to learn anything. All right? Okay. So let's move on to question 3. So the teacher recorded items purchased, 28 calculators, and 11 measuring tapes. And the amount spent was $673.50. Okay? So write an equation to represent the relationship between the numbers of calculators and measuring tapes, the prices of those supplies, and the total amount spent. So you've been doing this, okay? So let's just go ahead and I don't know why it's not letting me record it. I might have to make it bigger. So let's go ahead and give that a try. So here's what I'm gonna, nope, it's being glitchy. Oh well. So you would write 28C plus 11M equals 673.50. Okay? Let's see if this is going to work. Well, let Mrs. Heinzman pause and figure out my my technical difficulty here. There we go. I refreshed the screen and it came back. So let's do this. So we've got 28C plus 11M equals 673.50. Okay? Done. So now let's answer some questions. How is this equation related to the first two equations? Please pause your video and think about it for a minute. So I hope that you actually did pause your video and think about it. But if you think, hopefully you realize that this is just the other two equations added together. Okay? And in this equation, what do the solutions mean? Okay, and once again, it hasn't changed. We're talking about calculators and we're talking about measuring tapes. We know how much each one costs and we know how much money the teacher spent. So these two variables, the solutions that make this equation true, are the same type of thing. It's the combinations of calculators and measuring tapes that make this equation true. Okay, so how many possible solutions does this equation have? Well, it's got a lot. It's got a lot of solutions, right? It's a line. Every point on the line is a combination of calculators and measuring tapes. Okay? So, answering these questions, and I want to show you how this looks in Desmos. So let's graph this really quick. So you should ask yourself, so look at this, young people. We graph this after we added the two together, and look what we get. The same solution as we did before. Why do you think that is? Think about that. Why does it make sense for a third equation that is the sum of the two equations in the system to share a common solution? Okay? And think about this last question too. Were we able to add or subtract them without graphing? We talked about that a little, but the answer is no. No, we could not. Okay? So now we have built on this activity. All right? So let's take a look at the synthesis of it. They showed you what I'm showing you. Okay? That the answers are the same. Okay? Why? Well, we just added two things that were true together. And the fact is that after adding these together, we still end up with one solution. There is one set of calculators and one set of measuring tapes that add up to this amount of money. Okay? So hopefully you're starting to see that this makes sense. All right, thank you for listening. I'll see you in the next video.